the definition of a corporate bond, the coupon rate is different than the yield to maturity. And if you look at this slide, this RD basically is a return of the bond. D stands for debt. And you have a coupon rate, which implies how much coupon the bond would generate each year or each period. And the coupon rate indicates the cash flow. And this RD, we also call it yield to maturity. That is the return of the bond, and that is also the discount rate we use to discount the cash flows. And if the coupon rate is less than the yield to maturity, the RD, then the bond sells at a discount. That means the bond's price right now is less than $1,000. And we know that no matter for what kind of bonds, no matter corporate bond, treasury bond, municipal bond, or at what time the bond is sold, it could be right now, 10 years ago, or 150 years ago, the bond's face value is always at $1,000. And right now, if the bond's price is less than $1,000, we call it discount bond. And the only thing that determines this bond is discount bond is that the coupon rate is less than the discount rate, which is the yield to maturity or the return of the bond. And if the coupon rate equals to the return of the bond or yield to maturity, then the bond sells at its par value. That means the bond's price in the market right now is $1,000. And if the coupon rate is greater than the yield to maturity of the bond, then bond sells at a premium. That means the bond price is above $1,000. In the previous Excel exercise, I have shown that both discount bond and a premium bond, their price would approach to a $1,000 par value as maturity approaches, or there's a less time to maturity. And when the bond is due, right at the final date, right at its maturity, both of their prices would be $1,000. And right here, it also shows that if the yield to maturity rises or the discount rate for the cash flow rises, the bond price would fall. So there is an inverse relationship between the interest rate right here and the bond price. And here is one exercise that requires you to solve for the yield to maturity. As I said, yield to maturity could be many things. That's one of the challenging part of the chapter. It could be the discount rate for all the cash flows to get you the present price of the bond. It could also be the holding period return of the bond or the required rate of return by the investors. And in this exercise, you see that the 9% coupon rate, well, this implies cash flows. 9% annual coupon means each year the company is paying $90, and that's a 9% of $1,000. And then 10 years later, when it matures, it will pay a lump sum face value of $1,000. Right now, the bond is selling for $887. What is the yield to maturity? So essentially, you are solving for the interest rate in this time value of money problem. And you just hold the n equals to 10, the payment is 90, the future value is 1,000, the present value is 887 negative, and then you solve for the interest rate. So this is how exactly you do it. And you can also lay out all the cash flows and the discount rate in the formula and plug in all the necessary numbers in the formula. You solve backward for this discount rate RD. And in Excel, this is how we do it. I just use a space right here. It is the interest rate. I use the rate function, and I have 10 years for the bond. Each year I receive $90 payment, and my present value is 887, and I want this to be negative because if I pay money today, I will receive money in the future. The coupons and the $1,000 face value is what I receive in the future, so today I have to pay. So that's why the present value there, 887, is negative. And then hit enter. So this is my yield to maturity, 10.9%. This time it is a premium bond. In the previous exercise, you know that the coupon rate is 9% and the yield to maturity here is 10.9%, and the price of the bond is 887, and this is a discount bond. This is something we know from the previous exercise. And now still the coupon rate is 9%, and the price is changed to, you see, 1134.2. So this time you have a premium bond, which means the bond price right now is about $1,000, and then you solve for yield to maturity. I simply drag down the previous calculation, and the only thing I need to change is the current price of the bond. I change it from negative 887 to negative 1134.2, and then I hit enter. As you can see that if my interest rate is going down, then my coupon rate still holds the same, and then the price would be higher than $1,000. And I can also show you a chart. So let's say this is the yield to maturity. It could be from 0% all the way to 20%. So I put a 1% underneath that. Let me just zoom out so we can see the bigger picture. And all the way to 20%. Keep zooming out. And then what is the price of the bond? Then with the same term, I will solve for the present value. And here, the yield to maturity is my rate. And this is a 10-year bond. Each year, I receive $90 coupon payment. And 10 years later, I'm going to receive $1,000 face value. And this would be my bond price right now in the market. I'm going to convert to a positive number to make it look like a price, not a negative cash flow. As you can see, when my yield to maturity increases, the bond price decreases. That's because for the same cash flow, when there's a more discount, then the present value would be less. And I can also plug them in at the same chart. This time I just use this chart, okay, this scatter chart. And you will see that the price declines as the interest rate goes up. And there's an inverse relationship between price and yield to maturity. All right, and here are some definitions. In your exam, this could be part of the conceptual questions. You will see that current yield is annual coupon payment divided by the current price. And this is pretty straightforward. Current price is how much you invest in the bond today, and your first payment is reflected in your annual payment. And then when the bond matures, you will get the face value if you hold that long. And definitely you can sell it the next year or any time from now. Then you will get the next current price instead of the face value. But for this current yield, it equals to annual coupon payment divided by current price. The capital gains yield is also pretty straightforward. It's the change in price divided by the beginning price. You see that although the formula is pretty easy to comprehend, still people make mistakes. It is the change in price. You should use the later price minus earlier price divided by the earlier price. Just remember, you're going to use a new price minus old price, the difference divided by the old price. And the expected total return is the yield to maturity. That is the return rewarded to the investors, or the investor required return based on the risk level of the bond. As I said, yield to maturity could be many things. If the investor requires the bond to pay 10%, then the bond will be paying the investor 10%. And that's the yield to maturity. And it has two components. One is the current yield, which is from the coupon payment only, and another is a capital gains yield. It comes from the change in price of the bond. All right. So for the calculation, it's straightforward. You can just keep using the formula and plug in the numbers, and I don't think that's too challenging. So the next part is a little bit tough. We are dealing with a semi-annual bonds. So semi-annual basically means the bond coupon is delivered on a semi-annual basis. What change here in your calculation is instead of having n years, you have a n times 2 periods. And for each period, your return or the interest rate will be half of the annual rate. And then for the present value and the future value, these are still the same. However, for the payment is cut in half. If each year the company is paying $90 coupon, then for each semi-annual period, the payment is $45, half of the 90. All right. So this is how we solve for semi-annual bond. We're gonna convert 10 years to 20 periods, 13% interest rate to 6.5% semi-annual rate, and $100 coupon payment each year to 50 coupon payment per 6 months. And you solve for the present value based on all the given numbers. And here is a question about callable bonds. So callable bonds is something I mentioned at the very beginning of the chapter. The corporations call back their bond when the interest rate falls. When interest rate falls, you can, as a borrower, the company can find cheaper loans and pay less interest to the investors. So they will use the cheaper loan to replace the current loan, which is relatively more expensive. So they will call back the current loan. And this bond gives you such terms, and it also has a callable terms. It can be called back after 5 years, and of course, the callback price will have some premium. You have 5% of premium, which is $50, and you are required to solve for yield to call. All right. To solve for yield to call, you should know how long the bond was held by investor within this 5 years until it's called back. And the only thing you need to adjust here is the future value, which is your redemption value. It is the face value plus a call premium. Remember, I said in order to call back the bond, the corporations or the borrowers have to give the investor a little bit of sweet to make the deal smooth so the investor can sell back the bonds to them. And also the number of periods would be changed. 10 is actually for 5 years, and you have a 10 semi-annual periods during 5 years. So 10 stands for 10 semi-annual periods. And the payment per period is $50 as the company is paying $100 each year. And then you solve for the interest rate, which is the yield to call, but you should know that this interest rate has to be annualized to the final yield to call. So the Excel or the calculator output here would be 3.765, and that is only a semi-annual rate. The yield to call, just like yield to maturity, is an annual term. Once you have a 6-month rate, you have to annualize it by multiplying it by 2 to get the annual rate. Now it's the happy time to do our assignment. In assignment number 2, question 1 is about bond valuation. You are looking at a bond to invest, and this bond pays interest semi-annually, and this is very important information. And it will mature in 8 years. Its coupon rate is 9.5%. Face value is always $1,000. And right now, the bonds in the market is selling for $872. And here are the questions you need to answer. First, if your required return is 11% for bonds in this risk class, what is the highest price you would be willing to pay? And second, what is the yield to maturity on this bond if you purchase them at the current price of $872? And last, what would be the yield to call if the bond is called back in 3 years with a call premium of 4%? In order to answer all these questions, you first need to know what are the specification of the bond, or what are the fixed terms in this bond contract. So first of all, you should know that the bond face value is always $1,000, and it also has a coupon payment. So you need to know what is a coupon per period. What is a coupon per period? It is $1,000 times the 9.5% coupon rate, and since this is a semi-annual bond, it has to be divided by 2 to get a periodical coupon payment. And then you have 8 years. That means you're gonna have 8 times 2 semi-annual periods, so that's 16. And the current price of the bond is $872, and that is the market price. The first question is asking you what price you would like to pay. So you need to know your price, and then you will need to compare to the market price in order to decide whether this bond is worth buying. So essentially, you're comparing your price against the market price. Okay, so how do you get your price? And you have your own required rate return, that is 11%, and this would be the discount rate for all the cash flows to generate your price. So essentially, you are solving for the present value of the bond, and you know the payment is from the coupon per period. And you also have the number of periods that's known, and the future value is also known, and also your interest rate. Your interest rate is annualized at 11%, but you are doing this work on a semi-annual basis, so you need to divide the 11% by 2 to get a periodical semi-annual rate, and then you solve for your price. If your price is greater than the market price, let's say with all this work done, you solve for the present value, and let's say it is $900, that's greater than the 872 market price, then you think this bond is worth more to you compared to the market price. So that means the market price is cheaper. So should you buy the bond? The answer is yes, because you think the bond's worth is above the market price, so you should buy it. And vice versa, if you think the bond is only worth 800, whereas it's selling for 872, then you should not buy that overpriced bond. The first question is actually the most challenging question. The second one would be much easier. The second one is about solving for the yield to maturity, which is the interest rate. So you solve for the rate, and you know the future value is $1,000. The payment is the coupon per period, and you have the number of periods. And then this rate, I have to say, it is not your rate, it's the market rate. Okay, this is the market rate. Market rate is the yield to maturity. This is a market future determined by all the buyers and the sellers in the market. Then you will come up with the interest rate using the rate function of Excel. All right, since this is assignment and this is not an Excel project, so I will just let you do the rest of the work. And of course, your ultimate decision will rely on the comparison of your rate against the market rate. So let's say if your rate is greater than the market rate, that basically means when the market return cannot satisfy your required return, so you should not buy it because you require more return than the market. And if your rate is less than the market return, so that means the market gives you more return than you actually require, then you should buy this bond. Question C, if the bond can be called back in 3 years with the call premium, what is the yield to call? And yield to call is another annualized rate. You again are going to use the rate function of Excel, and you know this time the N is 3 years, and you have 3 times 2, 6 semi-annual periods. So your N is actually 6. And the coupon payment for each period, no matter for 8 years or for 3 years, for each semi-annual period, this still is your coupon. And the present value will be that $872, just like the present value for yield to maturity. Okay, so the present value will be $872, and I put an active sign in front of it. You should know why. All right, and the future value this time is different. Future value is not that 1,000 face value. It actually has a premium added in there to sweeten the deal, to make the investors more willing to sell back the bond to the corporation or the borrower. So this would be $1,000 times 1 plus 4%. So it should be a 1040. That is the future value in your calculation. Just to note the important parts. For question B and question C, your present value should be the current market price. And for question A, you are solving for your own price. All right. You see the difference? Your price against the market price, your rate against the market rate. And lastly, you should know that for yield to maturity and also for yield to call, these are both annual rates. So when you have a rate generated from your Excel calculation, it is a semi-annual rate. So you need to multiply your final output by 2 to annualize the rate from a semi-annual rate to an annual rate. So both of the rate output will be multiplied by 2. And for more detailed Excel operation, I have introduced in chapter 4 as well as in the previous lecture.